tan of 3x equals tan of 45 minus 2x. Again, just 2x plus 3x equals 5x, which is 45. And then we're subtracting the 2x in order to get 3x equals 45 minus 2x, and then taking the tangent on both sides. Okay, and before I start, what I'm going to do when I work through this, I'm going to make a substitution just so I don't have to keep writing tangent over and over again. I'm going to say u equals tan of x. Okay, so to start with, let's write out our left side, tan 3x, our triple angle formula, and that's just going to be 3u, let's use tan x, minus u cubed, 1 minus 3u squared. Okay, so that's the left side. Start with that. And then for the right side, we're going to use this angle difference formula. We're going to say where this is A and this is B. So we're going to say tan of 45 minus 2x is going to equal tan of 45. I'm not going to write the degree, but we're assuming degrees here, right? Minus tan of B is tan of 2x over 1 plus, again, tan of 45 and tan of 2x. But a couple things, and good, nice simplification again, why we use 45 is tan of 45 is just 1. Tan of 45 is 1 there. And we have our double angle formula for tan of 2x. So we can write this as 1 minus 2u, tan x is u, 1 minus u squared, all over 1 plus, same expression, 2u, 1 minus u squared. Then we'll just, let's multiply through by 1 minus u squared, top and bottom, and we're going to have 1 minus u squared minus 2u over 1 minus u squared plus 2u. What I'm going to do, I'm actually going to just change the signs on everything. So we're going to say, and change the ordering of this. So we're going to have it like multiply by -1 on top and bottom, just to make this a little nicer. I probably don't need to do this step, but I feel like doing it anyway. So I can write this like this. I don't think I needed to do this, but I just did it. Okay, so this is going to be our right side, and then here, let's bring back what we had here. So we have 3u minus u cubed, 1 minus 3u squared. And then for the next step, all I'm going to do is just cross multiply. Okay, so here's what we have on the board after I moved everything all into one side of the equation. And even though we have this big polynomial, it's actually not too bad, because if you look at it, we have these matching coefficients. So all the coefficients add up to 0, which means if you just plug in 1 into this, you'll see that this equals 0. There's like the -5 and the +5, the -10 and the +10 cancel. And if I put 1 into u to the 5th minus 1, the whole thing's going to equal 0. So, but how can we use that? So I want to do a little convenient, we could try to just factor u minus 1 out of that, but that's a little, we could do it with polynomial long division. But what I did, I actually grouped the terms. So I said, I brought the u to the 5th minus 1, bringing this here. Then I said -5. Let's see, we can write that, taking these terms and then doing our terms with 10. We could say -10, factor u squared out of that. I made a mistake here. We have to factor -5u out of that, and we have u cubed minus 1. And then what you'll notice, you can kind of see that we can factor, then we can then factor a u minus 1 out of this and a u minus 1 out of this. So let's see, this is actually going to be u minus 1, u to the 4th, we got our minus 5u, we got our u minus 1. The factoring of this is going to be u squared plus u plus 1. I'm not sure what you call it. That's, I guess, difference of cubes. And then we get minus 10 u squared u minus 1. And then we've got our common u minus 1 term for our one root that we can just pull out of the whole thing. But so you might be thinking, okay, but 1 is actually a solution, right? If u is 1, but if we go back here and we say, okay, 1 is our answer, it doesn't make sense because we're looking for the tangent at 9, and there's no way tangent of 9 is going to be less than 1 because a tangent of 45 is 1. So that's going to be an extraneous solution. And so what we'll do is we'll just cancel that out of here because it's not going to help us. And then so we have what we have. We have everything else here, and we just need to simplify again. So let's distribute this back, and this, well, there's nothing to distribute here. So this term is going to be minus 5u cubed minus 5u squared minus 5u. Then I'm just going to combine terms to simplify a little bit. So we're going to have u to the 4th. Our u cubed term is minus 4u cubed u squared, looks like, but we got a u squared there. So we got minus 14u squared. U terms, we're going to have minus 4u, and then I think we just have plus 1. Yes. Okay, good. So you see we've got our term a little bit more simplified. But again, now we have this, it's kind of symmetrical, right? So I think we can do something with this. Again, I'm going to bring my 1 over here, so we'll have our u4 plus 1. I'm going to factor minus 4u out of these two terms. And here we're going to have u squared plus 1. And over here I'm going to have my minus 14u squared. Then what I want to do is I actually want to turn this into a quadratic. And how we're going to do that, I'm going to look at this thing as u squared plus 1 squared. Now, but that's wrong, of course, right? Because if you multiply that out, you get a u to the 4th, you get a 1, but you get this other piece, you get 2u squared. So we're adding a 2u squared, we'll just subtract the 2u squared. And I bring it all the way over here because I want to group it with a similar term. So then, let's just rewrite this a little bit. We're going to have u squared plus 1 squared minus 4u u squared plus 1 minus 16u squared. And then the interesting thing here is if I just kind of do a substitution, we'll call this thing a. I end up with a quadratic in A. Yeah. Okay, so I have my quadratic in A, and what I'm going to just do is I'm going to use the quadratic formula. So let's do that. We're like, okay, here's our B term, here's our C term. That's kind of confusing because in a quadratic you have an A, but we get that. We just have that 1 in front. Okay, so quadratic formula, we're going to have 4u plus or minus b squared is going to be 16u squared minus 4. A is just 1 and C is minus 16u squared. all over 2. And let's just do a little simplification on this piece to clean it up first. So this is going to be, let's see, these signs are going to cancel. We got a 64. This is going to be an 80u squared in there. Okay, so we're going to end up with over here 4u plus or minus square root of 80u squared over 2. Okay, 4u over 2 is just going to be 2u plus or minus. We're going to have a u coming out of this square root. And let's see, 80 is actually 16 times 5. But the square root of 16 is 4. So we're going to have 4 over 2 square root of 5. Again, that's going to cancel. We're left with 2u plus or minus 2u square root of 5. So next we're going to put this in the form like as if we factored it, as if we factored this polynomial. So we're going to have, but we're going to bring back our u squared plus 1 as a minus the first root, which is 2u plus 2u square root of 5. And then we're going to have our a, which is u squared plus 1, which is u squared plus 1, minus the other root, which is the negative of this, which is 2u minus 2u square root of 5. And then I want to rearrange this again. So we're back in u. I want to rearrange this again so that we have these as 2 quadratics. So we're going to write this one as u squared so make this look like a quadratic, which it is. So we'll write that like that, and then we'll write this one we're just pulling out the u here to make this look a bit nicer. Okay, and then we have 2 potential solutions here. So again, we need either this first expression or the second expression to be 0. So let's try the first one, and we'll again use the quadratic formula to solve for u on this piece here. So we're just going to have minus b, which is going to be 2 plus 2 square roots of 5 plus or minus this thing squared, b squared, minus 4ac, but those are just 1 and 1, so that's just going to be a 4 there, all divided by 2. Then let's just focus on the square root first, but that looks like the messy part. So we'll square that piece first. So we get 4 plus 8 square root of 5, just distributing, plus 4, and that last piece is going to be 20 minus 4. But the 4s are going to cancel. We're going to have 20 plus 8 square root of 5. Now let's go back to, we'll bring that back over here and let's rewrite this, but I'm going to start doing some canceling. So we can remove some 2's. We have a 2 in the bottom. So we're going to end up with 1 plus square root of 5. And then I'm going to take this 2, I'm going to write it as a square root of 4, just because I'll show you in a second. When I write it that way, I can then do some canceling here. And so let's keep going. We can have this 4 cancel with the 8 and the 20, and we're left with plus or minus the square root of 5 plus 2 square root of 5. We're going to reject the positive value, and we're going to take the negative value. And we're looking at 1 plus square root of 5 minus 5 plus 2 square roots of 5. And then what I'm going to do actually is let's compare this to the calculator value. And if we actually calculate the whole thing, we get 0.15838 ... So that actually matches with the calculator value for tangent of 9. So it's kind of messy, but this is actually the correct value, the exact value for tan of 9.